Okay, so in these 2 hours, well, no, in this 1 hour and something, what we are going to do is basically wrapping up the discussion we had on the panels, because these 2 perspectives are actually strongly related with the automation versus augmentation that we discussed, and partially also about understandability and explainability, more understandability. Before starting, just a reminder, remind to upload the slides on the link. It's on the instruction of the panel. There is a link, something baltia.polito.it/oncloud/something, to upload there the slides. They should be written uploaded, but if you want to double check, just ask me, and I can tell you if the upload was successful or not. And the second thing is, don't forget to do groups. You need groups for all the other exercises. So I'm telling this especially to the people that weren't here last time for multiple reasons. Okay, so 1 hour and something about this perspective on human-AI interaction. So the question we can ask now, after the panels, after the discussion we had, is, can AI, just like AI algorithms, AI system, and people really can work together or not? And we covered in the panel the first of this question. That is, should we design and develop technology, and in this case is speaking about technology in general, that automatize, option 1, automatize people action, replace humans, what in the panel we called artificial intelligence, and then we said it's basically automation, because automatize people action replaces human. Or we should try to augment people. We should try to augment people action instead of replacing, what we called augmentation. And is there a clear winner? And from the panel, we can say that there is a clear winner, that is augmentation. But some of you has some point in saying that we can live with both. We can have automation, in some cases it makes sense, like the vacuum cleaner, and we can have augmentation in the other cases where we need supervision, we need action, we need decision making from the person perspective. And linked to the first question, so we try to already to answer to this question in the panel, and now I'm going to tell you which is, let's say, one other possible question that is answer that is related to what we defined last time as human-centered AI as definition. And connected to this question is which kind, even if we decide for the augment way, or, well, especially if we decide for the augment way, which kind of human AI interaction, collaboration can we envision? And here I put some limits, like are we imagining full human control over an intelligence system, or no human involvement at all? Like I get information and then, but there is no real involvement in that part. And or we imagine full AI autonomy, or no AI at all. So this is another way to see augmentation and automation, right? Because in full human control and no AI, this is more than that. If we have full AI autonomy, that probably, if we have full AI autonomy and no human involvement, we have automation or augmentation? Automation. If we have full human control and a little bit of AI, we have augmentation. But these are other angles here. So we can have full human control and no AI, such as regular driving or any other action that does not imply a computerized system, or we can have something in the middle, like a little bit of autonomy, a little bit of human involvement, etc. So this is, while augmentation and automation are too extreme, these are dimensions that can represent this two extreme, full human control, no AI, or a little bit of AI, or no human involvement and full automation as the extreme that represent automation and augmentation. And clearly, as we said also during the panel, context is the king in this discussion, because it depends which cases. We again made the example of the vacuum cleaner, the autonomous driving, and many other examples. Also the virtual human, that according to what you're using it could be more replacing a person, or it could be actually more replacing a person to augment another one. So it depends on the cases. And so if we need to choose, we already choose a little bit during the panel. If we need to choose about artificial automation and augmentation, what we choose, what we are going to choose, if we really need to choose.
Augmentation.
How many say augmentation? Because also the non-panelist can, okay. And who say automation? Okay, you're not alone, there are two, so don't worry. Okay, and I have a picture for you about automation and augmentation that say a little bit which one I prefer, I think. So you can understand which is the augmentation, which is the automation, right? Mm-hmm. So do you know which are these two pictures? All of you? Okay, so what is this one? It's a WALL-E. It's, yeah, the Disney movie, Pixar movie. And okay, without, who never watched WALL-E? Okay, without spoiling the movie to them, what is represented here? What's going on here in this picture? Who are these people? People.
Humans of the future.
Humans of the future, and why are they so fit?
They don't need to do anything, they just lie down here and eating and watching.
They don't need to do anything, just sit there, eating, something will give them food and provide to their benefit and make them sleep and move from these chairs to the bed, from the bed to another chair, and to another chair to this, and they also go around. These are moving around the city, so they can go around, etc. This is one extreme way to see automation, right? This is totally automated. People doesn't need to do anything except drinking and eating and watching movies and barely speaking. And in the movie, also barely thinking, actually, right? The other one. Yeah, there's more, that's the name. And why it's augmentation?
Because the user using the suit is actually interacting with it and it becomes a superhuman.
Yeah, because the suits actually augment the person capability in a way, no? Make it fly, just for one example, right? This is augment physical capabilities, it's more strength, can fly, it's clearly all fictionary, but still, can fly, can, and also the, let's say, intellectual capability can get more information about flighting, other airplanes, and more sensor data, so can get understanding what's going on, can access to artificial intelligence to get information on what's going on somewhere else, etc., etc., etc. So these are two clear examples of augmentation and automation in extreme way. One is augmentation in a probably one of the, again, extreme way to say that. So it's a suite, a mechanical suites that can augment all the capability of a person that use it. And the other one is an entire environments that basically automate all the needs, basic needs of the people, so that they just need to do anything and stay there. And then if you haven't seen the movie, or if you are going to see the movie, you discover what's happened in the end of the movie about these people, but no spoiler here. So you can understand where is my slide preference, right? Not there, clearly, not here, clearly. But let's put this a little bit more in context, right? So why we call them artificial intelligence and why we call them intelligent augmentation. Let's go back to the origin for a while of artificial intelligence. So we have here two definitions of artificial intelligence. One of these being a prediction, and prediction, especially in technology, are always fun because they're always wrong from people, prediction from people. So Nobel laureate Herbert Simon, 1965, was saying that machine will be capable within 20 years, so 1985, of doing any work that a person can do. So this is one of the first, not the first one, but one of the first definition of artificial intelligence in the sense. Machine in some capacity, and again, we are speaking artificial intelligence, not machine learning, because here we didn't have any of that, but machines that are capable with some algorithms, with that mechanism, in 1985 to do any work, any manual work, any intellectual work, any knowledge-based work that a man, and you see that is 1960, that we would say today a person can do. Clearly not a great prediction, right? And 9 years before, John McCarthy said that to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. So a machine able to do any work that a person can do, and a machine that can simulate any other aspect of learning or any other feature of intelligence of a person. And it's from here that's early beginning of artificial intelligence as a term, as a definition within computer science, that these ideas of automation and replacing people start, because the original idea was replacing people, having machine doing the work for people, having machine simulate human intellect. And these are two early terms, and clearly defined artificial intelligence is not trivial, and we tried, right, in the first class, in the madness session. You give your own definition of AI, and we have seen that there were some similarities, some differences, and still there is no, nowadays, a unique and consolidated definition of AI yet. Intelligent augmentation instead. Let's skip for a moment Orbit's paper that you all read. Let's go in the contemporary definition of the other two. So Douglas Engelbart, the one that was mentioning the other day for the mother, the other day, for the mother of Odimo, the one that created the mouse. In 1962, actually all the project that included the mouse creation and many other things was called augmenting the human intellect. So same years, some people were working on the idea of simulating humans and having machine doing all the works that humans do, and other people like Douglas Engelbart that instead were working on augmenting the human intellect, augmenting the people. And again, the mouse is one artifact of this as a way to augment the capability of what people can do. And 1960, this is a transactional human factor in electronics, Licklider was speaking about man-computer human-computer symbiosis, where he was saying that the computing machine will do the work that can be made a routine and that must be done, so the needed work that can be routine, to prepare the way, again, to support, to give more time, to make space for people making insights and decision in technical and scientific thinking, in knowledge-based thinking. So again, in those years is where this distinction between automation and augmentation, this tension that started there and is still some way present nowadays in the scientific field, started to be between people, high calibrate people that try to imagine machine to replace work, to replace knowledge, to replace reasoning, and people trying to augmenting and preparing the way. So having also machine that do stuff, computing machine will do the work that is routinizable, can be done as a routine and must be done, so trivial work, but in that way to prepare the way for insight and decision in technical and scientific thinking. So these two groups started there. And just to put this in context, we are speaking about 1960, 1955, etc. Just to put this in context of where technology were back then. How do you imagine a computer in 1960 or 50? It's not like this. It's not a laptop. An entire room. So these people were thinking and imagining machine doing work instead of people, or machine thinking as people were thinking, or machine augmenting people, not nowadays with machine learning and Google and Gmail and data, but a little bit earlier with a little less tools. So just to put, oh yes, do you know what is direct manipulation, by the way? You met it in the paper. All of you. Who doesn't know what is direct manipulation? Okay, this is the definition of direct manipulation. Direct manipulation interaction style in which user acts on displayed item using physical, incremental, reversible action whose effects are immediately visible on screen. A classical example of direct manipulation is another example of direct manipulation is button cannot be also is not necessarily direct manipulation because you maybe a button on a wall doesn't change anything on screen, right? So it depends which button, where it is. But a button on a screen doesn't act on displayed object of interest using physical reversible action whose effects are immediately visible. No? These are actions you can do to perform a task, but one thing you probably do on a computer every day. No? Well, scrolling could be. Drag and drop. Drag and drop is an example, a classical example of direct manipulation because it's on screen. It's physical in a way. You drag and drop with a mouse, with a finger, etc. Is reversible. You can always go back. You have freedom to move from one position to another and go back to the previous position. There's nothing that prevents you. Instead, of an action of a button is not necessarily to be reversible. Depends. And the effects are immediately visible because you are dropping something from one place to another, and you see the effects of these elements moving. Also, scrolling is direct manipulation.
The whole mouse metaphor, direct manipulation?
Yeah, the mouse enabled direct manipulation, yeah. Indeed, you can click on a button with a keyboard if you want. Okay, just to go back. So let's put this in context. So this is what computer science looked like in 50, 60. So in 30, 40, this was the early stage of modern computer science. In 56, there was the first time in a research lab at MIT, So when those people were speaking about machine replacing people, and this other was thinking about machine augmenting humans, they barely had keyboard attached to a computer. 1956 was the first time in a research lab at MIT, so not even commercial, in a research lab at MIT, where there was direct keyboard inputs to computer. It's a totally different world than we have now. And HP introduced its first computer in 1966, and it was like this one. So not rooms, say sort of more personal, more sizable computer than an entire room, but it has a keyboard, good. But this was sort of what the people in those ages were speaking about these things with this technology at use. Just to put them in context, where we are speaking. And also, let's now use some example, also early example, to understand if this technology, these ideas, these came mostly from research, are more automation or more augmentation, to see if we get the difference properly. So, you ever heard about Vannevar Bush? Okay, or the title, As We May Think. No. Okay, Vannevar Bush was a politician, policymaker, and scientist in the US in 1945, and wrote this article for American scientists, I think. This was called As We May Think. And he said, consider a future device, blah, blah, in which an individual stores all his books, records, and communication, and which is mechanized so that it may be consulted with exceeding speed and flexibility. It is an enlarged, intimate supplement to his memory. And here there is, the Atlantic, not Scientific America. The Atlantic is still, you can access to that paper, is on the Atlantic. And remember, 1945. So 1945s mean that the computer didn't have a keyboard either. Just to put it again in perspective, the mouse, no mouse. Touch screen, they have no idea what it was, a touch screen. So it was just early start. And this person was thinking about a future device, clearly not now, in which to store this information. So we can have a quick look at the video that is from 2009 and was created starting from the pictures, the drawing in the paper. But do you, let's say, does it remind you something that we have now?
Kindle.
The what?
Kindle around the phone.
Yes, for the books, but then also records and communication.
Smartphone.
Let's do one more step. Smartphone or a computer, but do you have all your books, records, communication on a smartphone alone? No, not Notion.
On the internet.
On the internet. Okay, clearly smartphone can access to records and communication mainly through the internet. So this is considered one of the idea for which, so Tim Berners-Lee, inventing the web, used this as, said explicitly that this was one of the idea behind the web. Having something that store information and can be mechanized and consulted with speed and flexibility. 1945. And we can have a quick look at the video, actually. So that you also see how this thing was intended to be. This was called the Memex. So this is what the Memex should have looked like, clearly. It's imagination, it's Pictionary.
The owner of the Memex, let us say, is interested in the properties of the bow and arrow. He has dozens of possibly pertinent books and articles in his Memex. First he runs through an encyclopedia, finds an interesting but sketchy article, and leaves it projected. Next, in a history, he finds another pertinent item and ties the two together.
And ties the two together. That is something we will call a link. And then it's also stored in the here as personal reference. So it's also knowledge and storing.
Thus he goes, building a trail of many items. Occasionally, he inserts a comment of his own, either linking it into the main trail or joining it by a side trail to a particular item. His trails do not fade. Several years later, his talk with a friend turns to the Turkish bow. In fact, he has a trail on it. It is an interesting trail, pertinent to the discussion. So he sets a reproducer in action, photographs the whole trail out, and passes it to his friend for insertion in his own memex.
Well, then there is the picture of how the memex should have been done, hardware side, in theory. So this was, again, 1945, where computer were probably room size without a keyboard. Again, just to make this in perspective of what happened there. So the memex. What is the memex? Or let's say, what is this pre-version of the internet with a big desk? Is it more automation or is it more augmentation? Augmentation. Any other comments on this? Why it's not automation?
Because actually it's the user interacting with the machine that tells what to do. Actually, the machine does the manual work, like searching through all the texts and the documents, just to link between them, but finally the choices are made by the human.
Yeah, the choices are made by the human. It also can annotate things, can link things, can create its own knowledge base, a la Notion, in a way. Can create its own knowledge base and keep it for himself. And then you can also share this with this disk to another person if they want, right? So this is, again, it's not artificial intelligence. It's not. There is some intelligence in like finding information and then linking information and then saving and such, but it's clearly not the level of artificial intelligence we can experience, imagine now, also because it was a bit of years ago. Okay, another example. So computer graphics people, you know what is this, right? You should know what is this. Good, not well. This is, you know what is SIGGRAPH, however. You know what is SIGGRAPH?
Oh, yeah.
Yeah, what is?
It's a conference like on most advanced computer graphics.
Yeah, it's a main conference on computer graphics, we can say. And also SIGGRAPH is the name of an association that organized the conference. So they use the same name for both things. So this is, again, 1980. So none of you, well, almost, I think almost none of you was born, like. I wasn't born there, so it was before. And this is a paper, actually, there's also the video, that was called Put That There, Voice and Gesture at the Graphic Interface. So something more recent, something more virtual in a way. And this tool, again, this is a computer graphics conference, right? Right now it's more virtual reality, extended reality, but back then was also this kind of things. And And so let's see what's going on here. Just 1 minute. This is a demo of the year before of the paper.
Create a yellow circle there. Create a cyan triangle there. Put a magenta square there. Create a blue diamond there. Move that there. Put that there. Move that below that. Move that west of the diamond. Create a large green circle there. Oh, shit. Restart.
Here there is a little bit more intelligence, right? Because there is speech recognition and there is gesture also recognition. Put that there, right? And so understand what is that and what is there. So about speech recognition, 3 questions for you. Why do you need to point? Why do you need to talk? And what might go wrong? So why do you this person? So this is more automation or augmentation? Augmentation again, because it's help you in drawing circles and squares and in a, let's say, easier way. More natural speaking and with gestures. It's not perfect, right? Because at the end, say I want a big green circle and the circle was red. So, and the researcher there decided to put together 2 things: pointing and talking. Always. There is also always pointing and talking. It's never only talking. It's never only pointing. And if you think that could be also be done without much of pointing, like for moving stuff, one can say move the triangle west of the diamond, and at a certain point does something like this, but starting was move that west of the diamond. It's not move the triangle or the vocal description of where the triangle is west or other definition. Is most of the time always mix voice and gesture. So why to you? And what might go wrong?
Disambiguation.
Disambiguation?
For disambiguation of different situations. For example, if he doesn't point the object but only name it, if there are 2 objects that the system can mislead, can
Why the system cannot ask if there are 2 things? Why they designed that in a way not to go in that direction? Because this ambiguation could be an issue, and I can tell you one way to solve this ambiguation is move the orange whatever, and there are 2 of them, and the system say which one, and maybe highlight and put a number close to them. I can say 2, and so solved this ambiguation. Why they didn't go this direction? Because pointing is more natural than for ending space.
Because point is input and talk is function. So if you give the command to create an input physical in the mathematical input.
Yeah. Also in this case, probably they use pointing to select and voice to identify action. Not always, because when we say west of, so the movement, they mix the two things, but they probably had something like this in mind. What else?
It's faster.
It's faster. Well, yes, in theory it could be faster.
With a multimodal input, you can both be sure that the technological limitation can be overcome, and moreover, it's more immersive because you have more.
Yeah, more immersive, and multimodal interaction can actually, so multimodal means using multiple modes to inputs and output modes, voice, gesture, colors, image, sound, etc., videos, to interact with any system. And it's proved to be more reliable and safe on the perspective of making errors, at least. What else?
It's easier to identify what you are pointing rather than describe something.
Yes, it's easier to identify quicker. Yeah.
I think that like this type of interaction is like the perfect I don't know how to say that, like simile, not metaphor, but simile to the natural interaction you would have with real objects.
Well, I will probably grasp real object and move it.
Yes, but
I will tell you, move that chair there, probably.
yes.
So that is
But
more,
you say and you point.
Yeah.
So that's the same.
the same. Yeah, it's similar to what we do when we talk about with other people and we want other people to do action.
Yes.
Like, please go close that door.
Yes.
I'm telling you what, but also indicating which door to close, also disambiguity, etc. And if I say, please close one door, you either pick one or you will ask me which one. So there will be, again, disambiguation, also is intrinsic in natural language. There is one more thing for which they don't mix pointing and talking with only talking, because they could have, right, said, okay, create that a circle there. But then for movement, they could have only used voice. And we said, okay, disambiguation could be an issue, and it could be a little bit less faster, but why they decide, and it will be still multimodal, but
Because you can describe those shapes and colors with your hands.
I can, no, this, then, yeah, the opposite. I mean, why for, let's say, describing where to create, so let's say the alternative version of this is I'm using voice and pointing to create, but I'm just using voice to move without pointing. Why this is not preferable with respect to what they do here?
You have a more perception of the space, so more.
The perception space, I think, is more or less the same, because you are there, you created that
Yeah, but
in
you
one
know
way.
exactly where will be moved. And
You can be more precise, yes, and one more reason. The others are all correct. It's just
Because you don't have always a reference point where to put something. For example, if you don't have an object close to the point where you want to put it, it's hard to explain.
I can tell you that there are, I think, 10 different ways to solve the problem without using pointing. But still, it could be a problem, right? That's
Pointing is less subject to errors. Well, if I point there, the figure that I want to move moves there. But if I explain where to move,
I need to have some reference point, as is was saying, but I can divide the screen in squares, and then I can select the third square from top left. It's right, but one thing is still missing. It's easy. All of these is pointing and talking are easy than just talking for movement. This is right. It's not wrong. But there is one more thing. Let me repeat the question. I have version 1, that is the one of the Richard Bolt, that has, for creating, talk and point, for moving, talk and point. And there's version 2 from an alternate universe that has version 1, point and talking, and movement, only talking. Why is version 1 better, in a way? Same results, same performances, same everything in the end. Why version 1, the one of Bolt, could be preferable than version 2?
Universal design for accessibility.
No.
It is more accessible, like for everyone.
No, because you need to talk in both cases. So, and version 1. Let me repeat again. Version 1. Create, point and talk. Move, point and talk. Version 2. Create, point and talk. Move, talk.
More flexibility.
Because you don't change the rule.
You don't change the rule. It's coherent. You always do the same thing in the same way. Similar thing in the same way. You learn how to do stuff, pointing and talking, and you continue pointing and talking. It's not at a certain point, to move, I need to present a square because otherwise, while for creating I can point. It's coherent within the system. So this is about, it's a simple example, but if you think about artificial intelligence, coherence of behavior across the entire system, entire application is something that we should keep in mind. To keep is not that in page 1 or in function 1 there happens something interactively and then in another page something different. It's more coherent, it's easier to understand, it's easier to use. What might go wrong? Or, well, let's move on about people. How might it fail? So let's think about people now. How this system might fail.
I can't move my hand if I do something or...
Yeah, I cannot move for whatever reason, so accessibility now is the right moment, or I cannot talk for whatever reason, right? From serious reason, I cannot talk, that's it. Or in this moment, I have some medical condition that for this week I cannot talk, right? So it doesn't need to be permanent, it could be also temporary. Okay, so this, in practice, this was a research work, clearly focusing on computer graphics, so not an application for real world, but does this think about people that could create trouble. Okay, let's move a little bit more recent, and we in both terms, artificial intelligence and intelligent augmentation, there is the term intelligence. And also in your definition, someone said it's like a brain, replicating the brain, doing something about intelligence, the third hemisphere of the brain, and it's smart system, intelligent system, a lot of intelligence in these systems. How do we measure intelligence? How do you measure intelligence in an artificial intelligence system?
With a comparison between the human, how human resolves the problem in terms of time and results, and how the artificial intelligence resolves the same problem in terms of time.
You compare human performances with artificial intelligence performances as a way to measure intelligence. This is what you said, basically, right? But this is more about performances than not intelligence.
It also depends on what kind of intelligence you're measuring.
It also depends on what kind of intelligence we're measuring, but you know, artificial intelligence is, say, intelligence in the name, right? Intelligence augmentation is, say, intelligence in the name, and this intelligence system is intelligence in the name. So which intelligence are we measuring there? And which intelligence are we supporting there?
I guess mostly logical and mathematical intelligence. I would exclude emotional intelligence, for instance.
Okay, let's focus on the logical and knowledge-based intelligence, and not emotional.
I think that typically we measure intelligence with accuracy and so with the coherence with the output with the input data.
Yeah, that is accuracy and sort of performance again. So yeah, we don't measure typically intelligence directly. We measure the intelligence through derived form, the performance, the accuracy. We mentioned at the time precision, recall. These are all metrics that we use to measure some level. And one way that's classical way in an example is measuring man versus human. Human versus computer, and compare the two results. And so what you probably don't know what's going on here, but you can understand which is the context of this. So what's the people are playing here in this picture? Chess. And chess is a classical example of this human versus machine, right? To compare intelligence in a way. Except this is not that kind of chess. This is called freestyle chess. And do you know what is freestyle chess without looking on Google? Or ChatGPT? So why do you have computers and a chessboard? Here there's the picture is cut not on purpose, or because it was the only picture I found that was reasonable. But it has to do with the text that is written aside, that say we can try to measure what is intelligence was the joint performance of a task for a human together with AI. So how human and machine together can achieve something that a human cannot do, or do worse, and a machine alone cannot do or cannot do worse. And remember the first question of the second slide was, can really human and AI work together? And say collaboration is key. So given this, what do you think is happening here? Collaboration. What do you think is happening here?
Probably the computer is giving the user the best move to perform on the real chessboard.
This is called freestyle, exactly. This is called freestyle chess because there are two computers. There's also a computer here and another person here. And these are chess players, and they get support from the computer. So the computer is not visible on the screen, but on the slide is visible that on this computer here, you see a representation of the board on this computer. There is a representation of the board. And so the computer is playing the game, is following and giving information, trying to predict the next move using the same algorithm that it's used to play alone, but the person is the one that brings his own expertise, brings its own knowledge of the other person that is playing, and it has own style of playing, and ultimately decide, and then inform the computer, I took this decision. Wrong or not, right or not, still is the person that decides. This is actually called, it's actually something you can do, is again, freestyle chess. And everyone see only our own version of the chessboard. The other doesn't know which information one has access to. So is this again augmentation or automation? It's again augmentation because the computer is providing information, and then the decision is ultimately from the person that will also move the actual pieces on the board. Another example, cobot. I think this was also mentioned in one of the papers of the second panel, not totally sure. So cobots are these things here. It was part of a project of Carnegie Mellon University in Pittsburgh, United States. And they follow a model of symbiotic autonomy. in which the robots are aware of the context of their environments, but also of their limitations, of what they can and cannot do. And if needed, they ask help for humans. So it's not a robot that go around and you talk with. Well, you also talk with, but sometimes in help, like a child. So for instance, one thing I can ask the robot is go bring this object to another person. And that will go autonomously if you know if the robots know where is the other person. I can put a cup of coffee or tea on the board here, somewhere here in the basket, and the robot will go to the other office and bring coffee. But if I ask the robot, please go to the coffee machine and get me a coffee, the robot will go. But what happens when it reaches the coffee machine? It cannot interact with the machine. That means what needs, imagine your coffee machine here, the first one, what it needs to do to get a coffee for you. Yeah, but what it needs to do on the machine? Type the number, put the money, and grab the coffee when it's done. And for instance, this kind of robot doesn't have any way to get object manipulation, harms. So these robots, what we go? They will go to the coffee machine, and what we do? You said that before? Ask for help. They will go to the coffee machine and speak to someone, I need to get coffee for Luigi. Can you help me? And in the basket there are money for paying for the coffee. And the person will need to help to get the money, get the coffee, and then bring the coffee in the basket and say, okay, done. And then the robot will come back to me and bringing coffee to me. So this was, these 4 robots were actually used inside Carnegie Mellon, clearly closed space. And if you look at the video here, there's also some example of them moving around, interacting with people, etc. So this, again, symbiotic autonomy. It's more automation, it's more augmentation, it's a mix of both. It's mostly augmentation, but there's also a good part of automation, right? Because if I need to ask, go to the door and welcome people by speaking, I'm just, there are things that this robot can do without any help. It's replacing someone that say welcome, 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 because it can go. Let's go to the elevator. Let's imagine there is an elevator here and pick this person. And so go there and show on the screen the name of the person, and then as soon as the person approach, say follow me. So there is no need to help. So in that case, is replacing me going to the elevator and pick a person. But when the robots know about some limitation, then it asks for help, and in that case is more augmentation. So here there is something that has a high level of automation, but can also have a good level of augmentation because it needs help to do some operation. Physical operation, but also, let's say, there's a reasoning limitations, also conceptual limitation.
What does it do when it has no input?
What do you mean?
Nobody asked to cover anything. Well, it's idle or just
It's idle.
for
It's typically, it's like this in these pictures. Stay there until someone gives some task to do. Okay, so here we start to see something that's trying to mix the two approaches. So in general, even in the case of robots, who should have the who should have the control, who should have a command between humans and AI? In general, humans or AI? Humans should feel to be in control. That doesn't necessarily mean that they have control, but they should feel to have control, always. So you can also have the Roomba going around, but you give the idea, the impression, you can have some buttons, etc., to give control on the thing. So feeling to be in control is just enough for people to say, okay, I'm fine, even if they don't have the full control, but feeling to have control on their life and the surrounding. So when we put intelligence, whatever we define them, in things, the people that we use those things should have these three characteristics. They should be comfortable with the action made by the intelligence system. They should understand, again, understandability, why some action, maybe not all action, are happening, and maybe they will need to explain also, as we said before, and they need to trust the system. And automation is typically met with resistance, so pure automation is met with resistance, but clearly can reduce the workload and avoid dangerous or trivial tasks or annoying tasks to be completed, so that the person can do other things, always keeping in feeling of control and comfortable with the action of the robot. Think about vacuum cleaner. If the thing is cleaning and you understand that the room is cleaned, you probably don't care much about other things, maybe just about data privacy policy, but as soon as you get just a comfortable and understanding how this thing works, you are okay with that, probably you will use Roomba for forever until you have a problem. So in general, we should avoid, and also we should avoid considering over-exaggerated expectations. So one important thing, and in this, for instance, ChatGPT and OpenAI are doing quite well, is setting the expectation. It's not enough to set the expectation, but at least you should set the expectation. So a few years ago, you heard everywhere that we have reached human parity in speech recognition. That's the dumbest thing said in the last 10 years, probably. That's still not true. We have not reached human parity in speech recognition. In some cases, between humans, we don't have human parity in speech recognition, in some languages, even. So that's totally, and saying that is creating expectation. So everything that speak. So if a very notable person, and you got it on newspaper, etc., we have now reached human parity in speech recognition. Speech recognition is solved. No problem in speech recognition anymore. I'm sorry for those who do research in speech recognition because it's not a problem anymore. We have perfect speech recognition. You set expectation to people. And so when people use something that uses speech recognition, expect to be perfect, to be like speaking with another human, and then they will go disappointed, and they will not understand why it's not working, and they will stop trusting the system. And also, there are some expectations that are pre-assumed. I was telling you the other day, that with things that speaks like Alexa or Google Assistant or Siri or these other chatbots, etc., you pre-assume that you can do whatever you do with another person. So if I can speak with it, it will understand my word. Thus, it has fully language understanding. I can say whatever I want, except it's not, right? Especially with chatbots, etc. You have to know what to say. Even with ChatGPT, there are many complicated ways to write long prompts to get the answer you want. So you need to know what to do. So setting expectation will help to be more comfortable, understand, and trust an intelligence system. And again, OpenAI with ChatGPT is doing sort of good with setting expectation in writing. It can provide wrong answer. At least try to set expectation. Then probably could do better, etc. But that's minimum thing to do. Instead of saying, ask whatever you want, you will get any answer you want. So just remember this: comfortable, understand, trust, and people needs to feel in control at least of what they are doing. No. Well, let's use this. You know what is, as an example, and then we move on. Do you know what is Amazon Go? What is Amazon Go? supermarket. Which feature has this supermarket with respect to the others? No employees. And so, how is it working? You don't even pay. You went there, grab things, and go out, basically. And you will eventually pay, clearly. It's not free. You will pay thanks to your Amazon account, clearly. So, what do you think? Well, if you know this, there's a video showing how this thing's working.
4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store so you never have to wait in line?
This is a promotional video by
No
Amazon.
lines,
so
no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
Yes, it was coming early 2017 in Seattle. This was promotional. And the United States is there in various cities right now, and it's also starting to appear in other parts of the world. In Europe, I think it's only in the United Kingdom right now. So, what do you think? I want the last one. You will be the last one. I know what you're going to say. So the last one. What do you think? Will you use it? You will feel comfortable here? This is clear. The video is very promotional. We use all this fantastic stuff, and you will be happy. So is totally fine? Is this accepted in your opinion? Or will be accepted? You will use it or not? And what's the problem?
I will that because I will use it once and then I may think, okay, if Amazon is using this, then someone else will use this, and I will want to be marked for life. I know everybody we are already all controlling every database possible, but even my face when I'm shopping, that's probably going to be a bit too much for me.
So any of you use this?
It would be creepy.
Any of you use this? Ever? No. Okay. So okay, we are speaking of just from the video, from the knowledge. Okay, so it will be creepy. So yeah, apparently this by the way, apparently it works. Actually, I have seen a few of them, and they were never crowded. So I don't know if it works because there are like 3 people inside in a given moment, so easy to track everything, or it works for real. But for the level of people that go there, it works. So a little bit creepy, Dan. It's cool.
If you have this level of automation, why should I even go to the store? Just deliver it to my home.
Just order on Amazon and let's bring it home. Why I should? Well, because you want the cupcake just in that moment, and you pass through and say, "Oh, cupcake."
Yeah, but we can have, I don't know, for example, delivery systems.
Yeah, you can have like Glovo Just Eat and just order a cupcake and bring it to you, which has another set of problems. But let's not go into them.
No, for me it's good because you can bring what you want. If you are, I don't also positive response in terms of medical stuff or other things. I think if the data is mine and I can use my data, probably know what I eat 1 week ago if I'm some trouble.
It can help you. Well, no, because you it's not needed that you buy something and then you eat them, right? But it could be a database of food that you for self-tracking of information. Go. Not Amazon. Go. Go.
I think the only thing on which I don't totally agree with this view is the fact that you don't own your data, so the data that you produce are owned by Amazon, and you are subject to what they want to let you use. And you are not free to use your data, and probably they will share your data with a lot of third parties, and they train a lot of systems with your data. So the power is not exactly symmetrical in this relationship between us and Amazon, I think.
You can continue to talk about data. Let's move on. It's right. Clearly, data is a big issue here. But I can tell you that these are, if you go in New York City, I think that in Manhattan there were like 3-4 of them, easily to find, and they will open one in London, I think, or they will just open one in London. So people are using them. Not again, if you pass through this, it's not the crowded supermarket with long lines. There are always 3-4 people inside, so there is people using it. So why we got our perception and say it's cool, it's creepy, it's terrible for data, and we have opinions, but some people is using it because maybe they find it cool, who knows. So why is this? And we also are, as one of you were saying before, a particular crowd of people because you are doing PhD and you have most of you have technical knowledge, etc., etc. And so data reflection are not, say, specific and in-depth based on knowledge that you have. So why do you think this is accepted? Even, especially if you don't think it's cool.
Because the hardest part is the people recognition part, and in the US and in the UK they already have CCTV, so they are accustomed to being recognized and have large scale tracking in that kind of data.
This is more on the technical perspective, right? Okay, they are used to have cameras everywhere, etc. But why do you think these 3-4 people every 10 minutes go in this place instead of choosing the supermarket next door?
Yeah, I think that maybe like this kind of shop works also like in big cities. Just in big cities, maybe I think that it won't work like in a small town because of not only like the novelty of the thing, maybe the people are scared about that, but more on the like quickness side point of view. Like in New York City, maybe I think of someone would just want to get coffee, maybe from Starbucks, like the equivalent of that on Starbucks, and they just want to grab their coffee and then walk to work, and they just don't want maybe to speak with people or stay in queue, and just grab the coffee and go to the metro and then
like a psychopath. Okay.
yeah.
That's for sure that in big cities these are going to be, they won't open this in a small city because it's not profitable enough probably. So it's clear in big city and there's more people and there's more opinion and people running around, etc., etc., etc. But so let's go back here. So to be accepted, we said people should feel in control, and how this put people in control, feeling in control. And the video show that.
That's simple enough to...
It's simple enough. It's the same mechanism used in other supermarket. You grab things, you enter with your phone, so you are in control because you are self-recognizing yourself, you grab things, and when you go out, if you see the video, that's old video, I don't know if it's still working like that exactly, but in the end you get, you see what you bought. So there is a closing the loop. I went there, recognize myself, I picked 3 things, and when I go out, I see that those 3 things were mine. So there is some level. It's probably comfortable enough because it's simple. You understand, because you understand. You go there, pick things, and buy. There is not much. And it seems cool, it seems magic, because you grab things and they are automatically recognized. So, wow, I grabbed this cupcake, a chocolate cupcake, and it's actually say chocolate cupcake here. And so this wow effect will also help with trust. And if you don't think much about data, if you don't think much about this kind of thing, clearly. But at first sight, say there is this wow effect that's make it acceptable by people. And then I don't know if they will ever open in Europe because some regulation that we have. Let's skip this. So just to close up, one trend that we are seeing now is something more close to the COBOL's idea to automate while augmenting. So put together two perspectives, and some of you mentioned that in the panel. Collaboration, we mentioned human-centered AI, is actually the definition of human-centered AI say that human-centered AI should focus on amplifying, augmenting, and enhancing human performance. So there is augmenting in the definition. Amplifying, enhancing are other way to say augmenting. In way, but it doesn't stop there. In way that it make the AI system reliable, safe, and trustworthy. So trustworthy, again, pop-ups here, because otherwise no trust, no field control, etc., but also reliability and safety. And what's the human-centered AI framework saying that instead of having this tension between automation and augmentation, between full human control and full computer control, full AI control, as we have now, or as we discuss now, we can imagine that in a different perspective. We can imagine that in a more, as I was saying before in the slides, we can imagine control, human and computer on one side, and this automation could be a low automation or no automation and high level automation. And so a human-centered AI tool that is, according to the definition, there is also a paper that describes all this stuff. It's quite recent, it's 2020. So 4 years ago, 3.5 years ago. It say that things that are high automation, high intelligence, and still keep high control or feeling of high control are reliable, are the ones that are candidate to be reliable, safe, and trustworthy much more than others. And then they may exist other things that are low automation and low human control, or high automation and low human control, like the Roomba. The Roomba clearly has high automation and low human control. You just start it, stop it, and fix it in case of problem. But the things that typically are more reliable, safe, and trustworthy are the ones that has high automation and high human control. One example of this thing that every of you use, I don't know if every day, but use frequently. And it's a software application on your smartphone, on every smartphone nowadays. That has high level of automation and high level of control from you. What is? It's a feature that every smartphone has.
Maps.
Maps? No? Another one? The what? No, the touch screen is not, no. An application, something that you got it in the smartphone. No. Well, it's not a lot of automation when you pay. It's more, there's not a lot of artificial intelligence, let's say. There's not a lot of control, actually. You have to learn what to say. So they will be probably midway here, somewhere here.
The alarm clock?
No, not the alarm clock. What's automation as the alarm clock?
Rings on its own.
That's more possession, like from an entity. The camera. The camera. Why the camera has high automation and high control? It does a lot of adjustment on its own. You don't have to if you want, you can disable things, but on their own it's stabilizing, and then lights, and then this, and then that, and then HDR, and then night mode, and then whatever they can invent. And why it has high control from you?
Because we can take photos.
Because you can decide what to do with the app. You can take photos, write photos, disable things, and you can horizontal photo, vertical photos, zoom in, zoom out. You have a lot of control on what you want to take a photo with, and also decide not to take a photo or take a video, etc. And so this is an example just in this paper of something that is very simple in a way, but nowadays is a lot of automation in it, a lot of artificial intelligence to create better quality photos, visible, let's say better quality photos. I'm not speaking of the pixel photos. And in a way you have full control because you can do whatever you want in the task of taking a picture, right? So thinking about this in a way to have, it's not really augmenting, because it's augmenting your capability as a photographer in a certain sense, but retaining you full control. So in the human-centered AI framework, you should consider that the things that are most likely to be reliable, safe, and trustworthy is the one that has high automation and high human control. And then there could be other things here, and they are still valuable and considerable. And okay, and this is basically what we said. And if we think about, again, human-centered AI and interactive, we can say that artificial intelligence, meaning more automation algorithms, if this enable interactive exploration and manipulation of object with a clear purpose, with a clear task, for human benefits, while being transparent, will keep control over data and algorithms, is one that, again, is able to be more trustworthy, reliable, safe, accepted, etc., etc., etc. And this is, again, another paper if you want to look at it. And all these papers say that in the end, interaction is the one that enable this collaboration, is one that enable this capability. And I've heard a lot of you speaking about interaction in the panel, so I don't think that I need to convince you much on this thing. And also the slides, you can maybe keep it as a reference if you want, give you 4 properties of well-done interactive human-centered system, that is interaction real-time, considering algorithm models and data, manipulation that will be observed always in real time, and exploring interactivities, how and why specific definitions, understandability and explainability in some sense. And in fast processes, the speed can be reduced to allow interaction if needed, even if you need faster output and faster, if needed, to allow interaction. So these are 4, and these are here are the 4: how human can benefit, understandability, what risk pose, partially understandability, and acceptance, who has control, because without control people are less inclined to use the things, and power over data, models and algorithms, something that emerged already before, and visibility of things, again, understandability and explainability. So the things that we have seen during the panel, and then I will close with this, it doesn't matter the rest. The things that we've seen in the panel are basically the foundation of what I'm telling you, just in a more systematic way with some properties. Let's close with this about understandability. So do you know what is HAII, or do you remember what is HAII? Well, you can see what this thing did at a certain point. So HAII was, well, and also the headline, I think it's very specific, right? Twitter taught Microsoft AI chatbot to be a racist asshole in less than 1 day, so in less than 24 hours. So what was HAII? A chatbot created by Microsoft. So what happened? Microsoft developed HAII and as a chatbot, interactive chatbot, learning from data that the chatbot see. And they deploy it not on Twitter first, they deploy it on WeChat only. And for a while, and it was working very, very good, perfectly. And they said, well, it's working so good, why we don't deploy it largely on Twitter? And they did in 2016, and less than 24 hours after, they shut down the service. Because as you can read there, it learned nice thing to say, like this one. And so, or this one, in less than 24 hours, and so they clearly needed to shut it down. But that got news, so Microsoft was recognized to be able to do something like this. So what's the problem with HAII? So why on WeChat it worked perfectly, and then they move it in another platform, and in less than 24 hours, it made a disaster.
Because the data is different.
In which sense that data is different?
Like I think that maybe on WeChat most of the data is more like not like Twitter, where there are like very strong political views about maybe.
Yes, in WeChat, yes. Probably in WeChat data were more, or the majority of information that HAII saw were more, let's say, neutral or positive, in a way less extreme, less in opposition than with respect to Twitter, or X, as we need to call now. But why? It's the same algorithm. What went wrong from the creator of HAII perspective? Or what was the problem for which HAII started to say things like that? Yeah, but that's the easy answer, people. But
So it didn't have boundaries. The country that used the social network. The country where the people use the social network. I think WeChat is more popular in a different country than Twitter.
yeah, but does from content of data, why on one thing never? So in a way, what's the problem here? Why sentences like this can be generated? What was missing in HAII to not generate sentences like this? A content filter, but why does it need a content filter? Does it have a goal? No.
It doesn't understand what it's typing.
It doesn't understand the meaning of words. So HAII was just grammatically correct. Subject, verb. And then I ate flowers, or I ate other things written here are grammatically correct. So I can replicate that. Doesn't know the difference between flower and feminism. So I can switch them in the sentence, and these are subject or object in a sentence, and it's fine. So just went. Clearly, on Twitter, there were more extreme positions, so HAII learned more the extreme position, but that was the problem. More than content filter is that technology wasn't able to understand the meaning of things, the concept behind things, or positive and negative perspective on single words. And so just the goal was create grammatically correct, human-like sentences, but without a real understanding what was saying in purpose. So on WeChat, it was lucky that it was more neutral environment or more positive environment, or never interact with extreme position or with a lot of extreme position. On Twitter, it ended up with a lot of extreme position and a lot of negative extreme position. So that generated this stuff. And clearly this was a bad publicity for Microsoft, and they needed to to shut it down everything, and they also get on newspaper. This, I think it was Wired. And this wasn't difficult to interact with that. It wasn't difficult to show. It was difficult to understand why that was behaving like this in one platform and not in the other. And the reason was that there was no really a difference in specific meaning. There's an associated meaning to the words. Just a word is a noun, can be after a verb. It's fine. When it's clearly not fine. Okay? So, and here we clearly said that to understand system, we also need to understand the goal, the functionality, and what's going on. And this is something that we covered, you covered, some panelists covered during the panel, the second panel specifically. Okay, we are a little bit out of time. We are also mid-course now, so that means that next class, you will not meet me until the last class, essentially because next class will be Alberto, and with the design workshop, etc. That it's the first exercise to do in group in class. Again, don't forget to complete groups, and don't forget to submit your slides on the link if you haven't done it by tomorrow, because after tomorrow the link will close. Okay? Have a good rest of the day and a good lunch, and see you in the future.